Hello, everybody. Good morning. Welcome to my talk. My name is Alex. Follow me at Twitter at AlexJLockwood. I'm an Android developer at Lyft. You can follow along with these slides. They're posted at j.mp-pathmorph, just so you don't have to take pictures during the talk or anything like that. So today, I want to talk about a very specific animation technique called path morphing. And when I think of path morphing, I kind of think of these as the prime examples. So on the left, this is from the Pocket Casts app. On the right, there's the Timely Alarm Clock app. And as you can see, unlike typical animations that sort of animate color, translation, scale, alpha, these are actually animating the actual shape of something, right? And it's kind of hard to wrap your mind around how this actually works. I remember the first time I learned how it worked, it was kind of like a mind-blown moment. It kind of just looks like magic until you actually understand how, what's actually happening. But my goal with this talk is kind of, by the end of it, hopefully you'll have a better understanding of how to, understand what's actually happening and how to actually create them. So path morphing isn't just specific to Android. It's actually widespread on the web. This is from an NPR article about gerrymandering in North Carolina. You can see it's sort of using time as a third dimension here to sort of show the before and after of what the districts actually look like. This is being rendered in Chrome. It's not native Android, but technically you could use an animated vector drawable to do exactly this. To kind of give the extreme example of what path morphing looks like, this is being rendered using Lottie. So with Adobe After Effects, you can create these crazy complex path morphing animation. This is actually morphing hundreds of paths at a time to get this really cool gooey looking effect. So before I go further, I just want to kind of give a really basic explanation of what's actually happening. So in order to animate an object's shape, you have to know how to draw it. And to do that, we use something called the SVG path data spec, which is essentially just a spec that describes drawing commands. So the simplest example is something like this, where you have this kind of floating pen on top of a virtual canvas, and the SVG path data spec tells you which commands to execute. So the first one is you move to this coordinate, you draw a line, another line, and we're done. And you get something like this. There are also, these are just two commands in the spec. There are commands for drawing curves, arcs. This is kind of just, I'm going to keep it kind of simple in this talk. I think I'm going to talk about M, L, and C. But it's a pretty large spec. So to actually morph this square into another square, you'd have to create an object animator. This object animator is animating the path data property of a vector drawable. As you can see, what it's actually doing is, you're morphing from one SVG path string to another SVG path string. And the obvious question here is, how does this object animator know what to do, during the animation, right? If you're animating alpha from 0 to 1, you are obviously animating, 0, 0.1, 0.2, et cetera. But what is halfway between these two path data strings? And to sort of think about it, what you can do is you can line them up vertically and kind of go through each pair of commands and ask what's halfway between these 2 points. And as you do it, you kind of ask what is halfway between 9.6 and 21.6? You get 15.6, and you just go through line by line, and you end up with this middle-looking string that would be used to render the animation at t equals 0.5. It should be clear from this, though, that one of the requirements is that both have to have the same number of commands, and they have to have the same type of commands. So to give a visual example of what this looks like, This is exactly identical to what you saw on the previous slide. We have a square on the left and a square on the right. You're just sort of morphing it from its starting position to its ending position. And on each frame, the object animator is like regenerating a new SVG string to use, and together it's creating this illusion of continuous movement. So this is kind of just a really simple example. You could obviously do this by just translating the X property of the view or something, but this under the hood is actually being rendered using a path morph. And to actually, I guess one thing to take away from this entire talk is that path morphing is just as simple as points moving from one location to another. So you have the points on the left, you move them from their starting point in using a straight line to their ending point. So that was a square to a square, but you run into some trouble when you're morphing a square into an octagon, right? Because now you have these 4 extra points on the right. They have no partner on the left. So what do you do with them? If you tried to do this on the web, you'd get something like this, some like really ugly animation that results from the fact that it doesn't know what to do with those 4 extra points, right? They're just popping into existence, and you get this really weird-looking effect that's probably not what you want. If you render this on Android, it'll just crash immediately when you attempt to inflate it, because the Android framework will be like, I don't know what you're trying to do with this, so I'm just going to crash immediately. And you should probably fix your object animator so that it is, you're morphing 2 compatible paths with each other. To fix this, what we can do is we can introduce the undercover octagon, specific to this case, obviously. And what I mean by that is what you can do is you can sort of you can alter that square so that it actually is an octagon, right? So here I'm adding these 4 dummy points, which they visually don't affect the appearance of the square, but for path morphing purposes, they're going to be compatible with each other now. And when you actually execute this animation, you get something really smooth looking like this. And this is going to be like a really useful strategy in general when rendering path morphing animations, because it's not often that you have 2 shapes that have the same number of points. It's kind of just like a happen by chance type thing, right? So that's a simple example using lines, but what do you do with curves? How do you morph curves? You can kind of apply the same logic. A cubic Bezier curve is just 2 endpoints and 2 control points. If you draw them out, you can see that once you morph them, it'll just, each point will just follow a straight line from its starting point to its ending point. On each frame, the object animator will regenerate, some path string to use, and it'll render them one after the other to create this continuous movement. So curve to curve is easy, but what do you do with a line to a curve? You can sort of use what I call, I guess, the undercover curve, right? You can make that line using a curve, right? So a cubic Bezier curve, when you draw its control points along the same line that connects its endpoints, it'll look like a line. It'll still be using a cubic Bezier curve command, but for the purposes of morphing, it'll be a curve command. So once you do that, you get this really smooth-looking animation, and it looks really nice. Taking that a step further, if you want to morph something like this, an octagon into a circle, you can apply the same logic. You can convert each line in the octagon into a fake curve. And once you do that, you can just animate the endpoints and the control points from one place to another, and you get this. And so I guess another issue that we have to solve, though, is that the order of the points actually matters, too. Right? It's not enough to just get them compatible, but the order of the actual points matters. And to kind of show what I mean by that is earlier we morphed a square into an octagon. The first point was at the top, and they're clockwise orientation, but what if you actually shifted the points in that octagon? These are both compatible with each other, but it would end up looking like this, right? Probably not exactly what you want. To give an example of something even worse is when you actually change the orientation of the points. So on the right, they're clockwise. On the left, they're clockwise. On the right, they're counterclockwise. And what that means is the points will translate in such a way that the shape will like invert in on itself in a really weird way. And this is almost definitely not what you want in this case. So to recap what we've learned so far, first is that when you're morphing paths, they have to have the same number and same type of drawing commands. To kind of help us out with this, we can use tricks like adding dummy points to the shapes that don't affect their visual appearance, and converting lines into curves. And lastly, this isn't going to crash your app, but the order of the path, the order of the points is going to be really important and can visually affect the animation. So before I go any further, I just want to kind of talk about how I even became interested in this. So it all started when I wrote a blog post about icon animation techniques. And the link's up there if you want to check it out. I was really proud of it. I wrote all these like interactive demos explaining like how you create different types of icon animations. But it was also kind of bittersweet because it took a really long time for me to write, and that was mainly because of the path morphing section, where I was dealing with I was getting assets that had like different orientation of points, and I had to do all this like math to figure out the exact location along a line where I wanted to add a dummy point. I had to continuously like recompile an APK just to test to see what it looked like, and I knew that I was kind of like writing this blog post that like was all about, oh, you should make icon animations, and knowing kind of in the back of my mind that it was like really difficult to do them. Along the same time, a developer advocate, Nick Butcher, at Google, he wrote this really cool blog post explaining how he wrote this little like jumping map pin type thing. And this uses a path morph to kind of curve the edge of that map pin. And we kind of got together and we agreed that it was way too hard to write these, and that was mainly because of a lack of tooling. Like there were no tools that made it easy to create path morphing animations. So to kind of recap the problems of what made it so hard, the first was kind of just the fact that design tools don't expose controls that make it easy. So for example, there's no way to easily alter like whether the order of points should be clockwise or counterclockwise. And when you think about it, from like Illustrator or Sketch's point of view, like this isn't really something that they should expose anyway. It's like it doesn't really usually affect the appearance at all. So why would they expose a control to do this? But for path morphing, it did affect us. Like it would make it a lot more difficult if the order of the points wasn't the way that we wanted. Another issue was that design tools don't allow you to overlap points on top of each other, which is a technique that you often need to use in path morphing when you're creating dummy points. And lastly, it was really hard to visualize in-between states. Like I mentioned before, in order to do this, you had to like modify the object animator strings or whatever and recompile the APK in order to like add it to some dummy app and then test it out. And it was really cumbersome to do that. So, given those problems, what we kind of thought was like, what if there was a tool that allowed you to create dummy points easily? It would like automatically convert lines into curves, so you didn't have to do the math to figure out all that stuff. And it exposed controls for you to like shift around the points or reorder the points. And lastly, just once you do all that, you export to SVG if you're on the web, or export to vector drawable or animated vector drawable for Android, and you're done. And this was how the idea of Shapeshifter was born, which was a tool I kind of wrote a couple years ago to kind of alleviate all of these issues. To give a really simple example, this is, I'm going to create a plus to minus morph. So what I did just there was I just dragged and dropped the plus and the minus icons into the web app. And I'm going to copy that minus icon path, create this path data property animation. And what it's going to do is going to create this little bar on the bottom, which you can kind of think of as the object animator. And once I do that, I'm essentially just animating the from value, which is the plus, the to value is the minus, and what it's telling me immediately is that the paths aren't compatible, right? Because the plus icon has 12 points and the minus icon has 4, so it doesn't know what to do. It's going to crash if you even attempt to animate this in Android. So what I'm going to do is I'm going to create this edit path morphing animation mode. And it's going to take me to this side-by-side view of the from value morph, the to value morph. And immediately it's telling me that I need to add 8 points to the plus, or 8 points to the minus up in the top left. And what I'm going to use to do that is this little plus icon in the top right to add dummy points. So right now I'm just adding 8 arbitrary dummy points. As soon as I do that, it will tell me that the paths are compatible. And as you can see, the result is super ugly because, again, the order of the points matters a lot. It's kind of inverting in on itself during the animation. So in order to fix that, you can see the issue is that the first issue is that the first point on the right and the first point on the left are in different locations. So I'm going to shift the points. So I'm going to get that first point into the same location as the plus. It still looks pretty bad, and that's because the order, the orientation of them is reversed. So what I'm going to do is I'm going to reverse the points on the right, and now they're both clockwise. Once I do that, it still looks a little bit ugly, and that's because the location of the dummy points isn't ideal. So I'm going to just kind of move them to this location. And once I do that, it looks good again, I think. Yeah. So again, if I went through that a little bit too fast, again, the slides are at the link I mentioned earlier. I'll also mention them at the end of the talk if you want to check it out. To give a second example, this is a more advanced example. I'm going to morph an arrow into an overflow icon. So I'm going to go through those same steps as I did before. I'm going to copy the overflow icon into this to value. It's telling me that the paths aren't compatible because they don't have the same number of points. But another issue actually here is that there are 3 shapes on the right and only 1 shape on the left, right? So automatically, Shapeshifter can't figure out automatically how to deal with this, right? In order to get around that, you can use a split subpath tool. So what this allows you to do is it allows you to specify, how do you want to split up the arrow icon, and an obvious way to do this would be to sort of, have the top part of that arrow morph into the overflow icon's top circle, and so on. There's also this pair subpaths tool, which allows you to specify which paths should morph where. So I'm just going to have the top one morph with the top one, middle one, and the bottom one with the bottom one. Once I do that, it tells me that they're incompatible again, and that's because the arrow has 7 points, the overflow icon has 4 points. So I'm going to add 3 points to this circle, and once I do that, it tells me that they're compatible, and the morph looks really nice, like this. Just because I feel like this is a technique that is really useful in general with path morphing animations. Sorry if I'm doing this way too fast, but what I'm going to do is I'm going to add a little bit of rotation to the morph as it's happening. So in order to do that, I'm going to create a group. I'm going to put that path in a group, and I'm going to animate the group's rotation from 0 to 360. And once I do that, you'll see that it looks a lot nicer when rotation is applied. And I think this is kind of because when you add rotation, it sort of like distracts the eye from the actual morph. So from the user's perspective, it just like looks a little bit more seamless and yeah, so like something like that. It looks sort of more fluid and nice. So that was this is what Shapeshifter will export. This is if you haven't seen it before, this is an animated vector drawable. This is just something you can drag and drop into your Android resources. It looks complicated, but again, it's just something you drag and drop and sort of never really have to think about. It also exports to SVG Spritesheet if you're interested on using an animation like this on the web. And again, all of this is at shapeshifter.design. So it's just a web app that you render in, that you like open up in Chrome. Yeah, so I encourage you to check it out. So here's some examples of morphs I made using Shapeshifter. As I was writing the tool, like how I debugged it was I kind of took like arbitrary icons from like a material design icon repository and just sort of asked myself, like, how would I morph between this icon and this icon? And this is sort of what I came up with. And obviously these are all pretty simple icons. So the next question was, how do you do something like this? In this case, the hippo has like 100 points. The elephant has 50, which means that you need to add like 50 dummy points, and you have to drag them all around in order to get like the exact thing that you want. And it was really annoying and took a long time. So, the next thing that I was thinking was like, is there like a way that I can automate the creation of this so that I don't need to manually drag and drop points? And this kind of got me thinking about something that I kind of alluded to in the video that you may have noticed called autofix. It's essentially like a tool that will like attempt to automate the creation of the path morph. It'll like figure out where to add the dummy points, how to order them in order to get like the best visual appearance. One of the whole ideas of Shapeshifter was to like not do this initially. Like there were tools that kind of automated everything for you, but me and Nick, as we were creating path morphing animations, we found that like it was actually oftentimes it didn't generate something that you wanted, and Shapeshifter was kind of an attempt to allow the user to have like total control over where dummy points are placed, right? But in this case, with that hippo to elephant thing, obviously it would be helpful to have something like this that can automate it for you. And if it didn't generate something that you wanted, then you can always have the option of like sort of dragging and dropping the points to the location that you want. So that's the idea behind autofix. How do you actually go about implementing this? So one of the first things that I sort of assumed was that the morph with the smallest like distance traveled was often the best. So you can sort of see the differences of like a morph where you're animating points like from like varying distances, and obviously like in this case, just the example on the right looks a lot nicer. There are just 4 points that are just staying exactly where they should be, and you're only animating those 4 top and bottom points to the new location. And I guess, yeah, this makes sense kind of intuitively that this would result in the best animation, because the shorter distance traveled means like the less likely it is that points will sort of like invert on themselves, creating these like really weird in-between states. So I took a crack at this. The first step was to just add dummy points. So I found that adding more dummy points resulted often in smoother path morphing animations. So you can see I'm just adding a ton of dummy points, just making sure that there are the same number of points on both sides. Once I did that, I sort of brute forced like the orientation of the points to try and figure out what orientation of points has like the smallest distance, like the smallest total sum of distances between the points. Once I find that, I can convert the lines into like dummy curves or whatever, and I get a really smooth looking morph like this. To kind of take this a little bit further, here's an example using this technique of just kind of morphing like random shapes into each other. You can see the green points are the points that are being added, the dummy points, just for the purposes of making the path morphing animation work. The pros of this approach, obviously, are that it's like a pretty simple algorithm. It's just a 3-step process. You add dummy points, you figure out the optimal orientation of those points, and then you morph them. So it's easy to implement. It oftentimes creates a really natural-looking animation. The cons are that you're adding a ton of dummy points here, which isn't ideal when you think about the fact that more dummy points means longer path strings that you're compiling into your application. Larger path strings means larger APK sizes. It means longer times required to like parse the vector drawable at runtime, longer time to draw the vector drawable at runtime since there are more drawing commands being executed. And it also just kind of defeated the purpose of Shapeshifter, I thought, because the whole point of Shapeshifter was to make it easy to have control over what the path morphing animation looked like. And I found that once you add all of these dummy points, it's like you're kind of stuck with something that's not easy to customize because you have like a million points now, and if you want to like completely reorder the points to get the exact morph that you want, it would require either just deleting everything and starting from scratch, or dragging a bunch of points all over the place to get what you want. So I kind of went back to the drawing board with this, kind of in search of a more intelligent way to automate these path morphing animations. And I remembered something from college called Needleman-Wunsch algorithm, which is a dynamic programming algorithm used in molecular biology to align DNA sequences. And I know that sounds totally random, but I promise it will make sense. So DNA is made up of nucleotides, C, A, G, and T. And essentially what this algorithm does is you give it two DNA strings, and it will create an alignment between the two. And this is really useful in like evolutionary biology if you want to like determine how closely related two animal species are, for example. It'll output something like this, where it'll tell you gaps, which are like, I guess, at along evolution, like at what point did nucleotides just get added or deleted to the DNA strands. And it'll tell you mutations, which are, at what point along evolution did like an A morph, change into a T or something like that. There are also extensions of this algorithm that allow you to give preference to certain pairings. So like if you know that C is more likely to mutate into an A, you can say, I want an alignment that prefers matchings of C and A over like T and A, for example. So back to path morphing. How is this even related? So I kind of was thinking about this, like, what if you could apply the same logic to a SVG path string, right? If you run this through the algorithm, ideally what you would get is something like this. So the gaps are, I guess, in this case, the dummy points that you would add, and the mutations are the incompatible commands that you would need to create like a dummy curve or whatever in order to get it to work. And using those extensions that I mentioned earlier, you can give preference to pairings where the points are really close together, right? So you can say like, I want to prefer pairings of L and L where the endpoints are really close together rather than like super far away from each other to get those like seamless animations. And once I kind of walked through that, I ended up with something like this, where the morph looks essentially the same, and there are not a ton of dummy points anymore. The thing that I really like about this is that it's really smart about where to add dummy points. So like, for example, the hippo's ear, for example, it's like a really fine-grained curve. It requires 6 or 7 cubic Bezier curves to get it to look exactly like what you want. Whereas, if you're morphing that into an elephant, initially the trunk is just, just like a single, like 1 or 2 cubic Bezier curves. So this algorithm allows you to kind of figure out, where should I like put a lot of points in order to get like a really fine-grained animation. In this case, it was smart enough to detect that it had to add all of these dummy points in the trunk in order to account for the hippo's ear. The cons of this approach are that it's an ON squared algorithm, but I figured that's okay because it's not affecting the runtime performance of anything. It's just a little bit extra work needed by Shapeshifter when you're running it in Chrome. And the results are really nice. Like you're saving like hundreds and hundreds of dummy points. So up until now, we've been talking about morphing single shapes. But what about this? What about this, like when you're morphing a donut into a star? And to do this, what you can kind of do is you can create, I guess, what I call a dummy subpath. So in this case, there are 2 subpaths on the left. There's only 1 on the right initially. But what I'm going to do is I'm going to create this dummy subpath in the star that doesn't actually visually show up at all to the user. What this actually is it's just like 10 or 20 points being stacked up on top of each other. And when you morph this, you get this really nice looking animation where the inner circle sort of like collapses in on itself in order to, when it gets to the, it's sort of like this like vortex looking thing, I guess. This strategy works in many cases. Like if you're morphing Texas into Hawaii, you can sort of like fade out the Hawaiian Islands by collapsing them into just like a point that just doesn't show up at all to the user. Obviously, this doesn't look great. The Hawaiian Islands are sort of like morphing on top of Texas as it morphs into the largest Hawaiian island. It looks kind of weird. So I kind of started thinking, like, how do you automate that? How do you automate like the splitting up of Texas into 8 different parts so that it morphs like really seamlessly with Hawaii? So in order to do that, what I kind of thought about was something called triangulation, which is common. It's really it's used a lot in like OpenGL and WebGL. GPUs tend to only like to draw triangles, and triangulation is kind of like essentially what it does is it splits up something into like a ton of small triangles so that it's like GPU friendly when they are rendered. So essentially what I did was I kind of ran Texas through the triangulation algorithm. What it gave me was a Texas comprised of like hundreds of triangles, which is okay because the next step is to sort of go through them, merge a triangle with its closest neighbor, and then repeat. So this is kind of like 99 triangles of beer, I guess, right? Like you're just going through them one by one, merging them, and when you're left with just 8 shapes, you're done. And once you do that, you can morph them. You can like pick, the subpaths that are like closest together, and you get something that looks really nice like this. And to kind of give like a really gratuitous example of what this looks like when you're morphing just random things to each other, here's kind of an example. In general, this works pretty well. The thing that is kind of tricky is that the triangulation kind of results in like slivers along the entire thing, which I've found to be kind of distracting in some cases. Yeah, like so, for example, here, like the slivers are sort of like horizontal, and it's not ideal, I guess, in this case. But I didn't actually incorporate this into Shapeshifter for this reason. But I don't know, I kind of wanted to share it because I thought it was pretty cool. So like I guess wrapping up, just to mention some stuff I've been working on with Shapeshifter. So here's an example of something I've been working on a little bit. So kind of like one of the top feature requests is actually adding the capability to draw stuff inside of the editor itself. So initially, kind of what I did was just require people to drag and drop SVGs into it because I didn't want to like re-implement Illustrator or Sketch or anything. But this is kind of my attempt to at least sort of do that. You can see I'm like creating ovals, and there's a pen tool and a pencil tool. What else? Yeah, you can scale them, you can rotate them. It's like a little snapping going on. And I guess this sort of allows you to, at the very least, you could drag and drop your SVGs into there, and if you just happen to like want to modify them after the fact, this would allow you to do that. This is all available at beta.shapeshifter.design, so I didn't actually commit it yet because I'm not finished with it, but if you want to check it out there, you can do so. And yeah, so to kind of wrap up what I'm talking about, this is kind of like what I envisioned Shapeshifter to be. This is Adobe After Effects. As you can see, it has a million settings. It's pretty complicated. Creating icon animations in After Effects is like essentially, it's like basically the simplest thing that you can do in After Effects, right? Like After Effects is used by people who are creating like crazy visual effects, or rendering like HD movies or videos or whatever. This was not ideal. It's also like $500 or something. It's not the easiest tool to obtain or use. And Shapeshifter, I kind of want Shapeshifter to be something like this, like a really slimmed down, free, open source version of After Effects that anybody can use and is easy to use to create icon animations. So here's information about it. I mentioned earlier, shapeshifter.design. It's open source. It's on GitHub. You can check it out. There's an open collective page where you can donate if you want. Here's some like awesome people who have donated so far. I think there are actually a couple others that I should add to this slide too. But yeah, thank you very much for that, by the way, if you're watching this on the video. So special thanks to these people who are awesome. I mentioned Nick. He's a developer advocate at Google. He kind of, during the initial design phases of Shapeshifter, he helped me out a lot. He gave me his ideas on like what he wanted to do, what he needed to do, how to make path morphing easier. Roman Nurik is a design advocate at Google as well. He helped me a lot with actually creating the web app. So he's kind of like an expert web app developer at Google. And Noah Veltman, who he doesn't do Android, but he's also kind of like really into path morphing on the web. He has a really cool talk called what's it called? Picking a polygon out of a hat, I think it's called. But essentially, it's kind of like what this talk was about. It's like a super in-depth look into path morphing techniques on the web. And yeah, I definitely encourage you to check that out. Yeah, so that's all I have. Again, Alex J. Locke was my Twitter. You can find the slides to this talk at j.mp pathmorph. So thanks.